Hello and welcome back to the 8-Bit Guy. So in previous episodes, you've seen that I've used a lot of Retrobrite. And I've used the same method that I came up with a couple of years ago where I used the salon cream combined with plastic wrap to keep it from evaporating. And that method has been more or less successful for me most of the time. However, as you have seen, there's been a couple of times where it didn't work so well. And I've received tons of emails over the last year suggesting to me potentially better methods of retrobriting. And so today, I'm going to start testing them. I've collected all the different chemicals and contraptions and devices needed to perform a test, and I'm going to do it highly scientifically. And the way I'm going to do it is with this keyboard. This keyboard is very yellowed, and it's more or less evenly yellowed, particularly from this side over. So what I'm going to do is I'm going to pop off all of these keys, and I'm going to clean them up, and then I'm going to try different methods on each key or set of keys, and then at the end we can compare and see which keys ended up working best on. And then when we figure out what the winner is, I'm going to use that method on this severely yellowed Macintosh LC2. In fact, it's almost darn near brown on the back. It's yellowed so badly. So we'll see how effectively we can treat that. So let's get started. The first contestant will be the tried and true salon cream, just so I have a base point of comparison. I'm also going to use regular hydrogen peroxide. This would not normally be possible, but because the keys are very small, I can submerge them in this. I had an email from a fan telling me that engine cleaner worked for him. However, when I went to the auto parts store, there didn't seem to be just one type, so I ended up buying engine cleaner and engine degreaser. Not sure what the difference is, but I'll test both kinds. Another email suggested to me to use sodium percarbonate powder. When mixed with water, this turns into hydrogen peroxide, I think. Another viewer recommended white vinyl dye. As this is not paint, I suppose there is a chance this might work. We'll see. And the last thing I'm going to try is my own idea, which is using an ozone generator. Now, the reason I'm doing this is due to an experiment that I did almost a year ago. Now, I didn't take any video of it, but what I did was I poured some hydrogen peroxide into a glass container. Then I put a small metal pedestal in there and I placed a yellowed key on top of it. And then I covered the top of the container and set it out in the sun. Interestingly enough, the key turned white even though it was never touching the liquid. Now, what this told me was that it was not the liquid causing the color change, rather it was a gas. However, it still required UV light because I tried the experiment again in the dark and it didn't work. So the question was, did the UV light affect the liquid, creating the required gas? Or did the UV light react with the gas and the plastic directly? Well, that's what I'm going to try to find out. Now, I'm not a chemist, but after doing some reading on the topic, I thought that maybe one possible result of this combination would be ozone gas. So I bought this ozone generator and I'm going to try it out and see what happens. The first thing I needed to do was remove some keys from this keyboard. Since the right side of it was yellowed worse than the left, I chose that side for my testing. These keys were very dirty too, so time to clean them. Many people have asked me if it's necessary to clean the plastic before retrobriting. To be honest, I've never actually tried it without cleaning, but if I care about something enough to retrobrite it in the first place, then obviously I care enough to clean it, so it just makes sense to do that first. Okay, so these are all clean now, but they do have one problem, which is kind of annoying. And it's these back sections. It makes it difficult, if not impossible, to get these keys to stand up straight. Not that this would be a deal breaker under normal circumstances, but for the purposes of this experiment, it would be helpful if they could lay flat. So I'm going to use some pliers and remove these little plastic pieces from the bottom. Try not to cringe too much, but I'm going to cut these little things off too. I have plenty of these keyboards that are in a lot better shape, so I'm just going to sacrifice this one in the name of science. In fact, I actually have another keyboard just like this that's broken that I could take the keys from to make this one whole again if I ever decided to do that. Anyway, you can see what I mean. These keys will be a lot easier to work with now. Of course, every good science experiment should have a control, and what better key to use than the control key itself? The only problem is, this is the only control key this keyboard has, and this keyboard is slightly more yellowed on this side than it is on this side. In fact, if you compare one of the keys I removed from the other side, you can clearly see a contrast, so the control key will not actually work as a scientific control, unfortunately. So instead, I'm going to use the equals key as the control, so it will get no treatment at all. So time to actually get started testing this stuff. I'm no stranger to the peroxide method here, so I'll use the number 4 key for this. Covering the top is not absolutely necessary, but sometimes bubbles will cause these keys to rise to the top, and I want to trap the gases inside the container. Okay, so I'm going to use the number 1 key next, and it will get the vinyl and fabric dye. So here goes. This looks more like spray paint than I was expecting it to. I'll have to let this dry, but I'm very skeptical of this. Next up is the number 8 key, and it will be the recipient of the engine cleaner. Wow, they weren't kidding about the foaming part. This stuff is like shaving cream. Well, I'll have to let that sit for a while. The number 3 key will be the recipient of the engine degreaser product. Well, that stuff looks kind of nasty. Anyway, I'll come back to this later. Next up is the number 5 key, and it will be getting the usual treatment that I'm known for, which is the 40% salon cream. Of course, that's way more than it needs, but oh well. And last, I'm going to use the clear key and the 7 key for the ozone test. So the clear key is going to get regular ozone, and the 7 is going to get ozone plus UV light. And the way I'm going to do this is I'm going to use these 2 bags. And I'm going to give these bags a little weight so they don't fly away. So I'm going to stick a couple of these old Eisenhower dollars in here. Alright, so I got this particular ozone generator because it has a hose. And that way I can direct the ozone wherever I want it to go. Now, when I turn this thing on, it doesn't start producing ozone right away. I've noticed it takes about 30 seconds to warm up. So I wait until I smell the ozone before I inflate the bags. So I just close up the bag as much as possible and then insert the hose in the corner. And that seems to work pretty well. Now for the next one. Okay, so these 3 things are going to get UV light. There's the regular peroxide, and then I'm using that along with the measuring tape to weigh down the 1 key in the salon cream because it is a little windy out here. And last is the bag of ozone, and the coins are working fine to hold that in place. Unfortunately, it is completely overcast today, so there isn't going to be a ton of UV light. However, the sun should come out later this evening or tomorrow, so I may have to wait until tomorrow to see any results. Actually, I forgot about the sodium percarbonate, so I'll put some water in this bowl and then I'll pour some of that in there. Okay, that's probably more than I needed. I'm going to cover it too. I put it outside, and after a few minutes I noticed some interesting activity going on with the sodium percarbonate. You can actually see some sort of reaction going on. Okay, so it's been about 24 hours, so it's time to look at some of the results. Now, I only had about 4 hours of sunlight on these items that I was going to use UV light on, but everything else has been sitting here for 24 hours. So let's take a look and see what the results are. Let's start by looking at the 2 that received the engine cleaner and the engine degreaser. Looking at these, I don't see any difference at this point, but let's go ahead and clean them off. So here they are. They look identical. And here's our control key, and well, I can't tell any difference. So unless there's some step I'm missing, I think the engine cleaner is not going to work. Now let's look at the vinyl dye. It's stuck to the plate here. Let me see if I can get it off. Alright, so what can I say about it? Well, I can't argue with the fact that it definitely looks white, but it doesn't look correct. It just looks like it's painted. I'll go ahead and clean it with Windex and see if it holds up to that. Okay, it really didn't affect the appearance any. Here it is compared with our control key. I'm not sure which one looks worse. Out of curiosity, I thought I'd try rubbing some alcohol on it and see if it would come off. I could see this vinyl dye being a solution in rare circumstances, but a keyboard would be the last thing I'd use it on. So it does appear that alcohol was able to rub off some of the dye, leaving the original yellow plastic underneath. So yeah, I don't recommend this method either. Next we'll take a look at the regular hydrogen peroxide, and it actually looks pretty good, which is not surprising since this is one of the tried and true methods I've used before. Here's a comparison with our control, and you can see it looks quite a bit better. And here comes the sodium percarbonate. This appears to have worked as well. Here it is next to our control, and there's clearly a contrast. Now it's time to take a look at the salon cream. This is a tried and true method for me as well, so I pretty much expect this to look good. I really only included it as a means to compare effectiveness between these methods. And here it is compared to the control. And notice there was no streaking on this key like the poor Osborne had. The last thing to examine are the two keys that got ozone gas. Let me take these out of the bag here. Okay, so interesting result. Both of these keys spent 24 hours in a bag filled with ozone, but only the 7 key got UV light along with it. In fact, comparing with the control, you can see that ozone by itself is apparently useless, but ozone with UV seems to work. However, if you compare with the key from the salon cream, you can see that ozone wasn't as effective. I imagine ozone would probably completely restore the plastic. It just probably needs more than 4 hours. And I have another experiment to show you. During the process of filming this video, I was contacted by a fan of my channel, Richard Blair, who is a professional chemist. And he said he had done some experiments on this, and he discovered that heat worked just as well, if not better, than UV light. And that's interesting because I know the Obsolete Geek and I had a discussion about that just a few months ago, and we were wondering what role heat might actually play in the Retrobrite process. So I set out to recreate Richard's experiment and see how it worked for me. I needed to heat hydrogen peroxide to 150 or 160 degrees Fahrenheit for about 4 hours. At first I thought about using the toaster oven, but the lowest setting it had was 200 degrees. My next thought was using the stove. These controls don't have exact temperature controls, so it will take some experimentation. I also noticed that it had a warm zone and a melt zone, so hopefully those can be set to lower temperatures. After all, I don't want to literally melt the plastic, but from what I can tell, that won't happen for ABS plastic until over 200 degrees Fahrenheit. Using an infrared thermometer, I was able to find a stable temperature pretty close to 160 degrees. I had also managed to locate some salon developer that is clear. In fact, you can see this stuff is not even creamy at all like the other stuff. It's just clear liquid, which is perfect. For this test, I'll use the number 2 key. I'll let that do its thing and check back in 4 hours' time. Okay, so here we are 4 hours later. I can already tell the key looks different. And here it is compared with the control. So let's take a look at all of these together. This is my control. This was ozone gas. This was ozone with UV light. This was the hair developer with heat. This was engine cleaner. Vinyl dye. Sodium percarbonate with UV. 3% hydrogen peroxide with UV light. The salon developer cream with UV light, and last is engine degreaser. Now I want to take a look at each of these and judge them on how effective they are, how long it takes, and how difficult it is. These 4 were simply not effective at all. The rest of these methods all work, and the only real difference is how long it takes to get the desired result. Keep in mind that all of my testing was done for 4 hours, so I've ranked them here with how quickly they worked, with the peroxide and the heat combination being the fastest result and the ozone gas with UV being the slowest. Difficulty, on the other hand, depends mostly on how large of an item you're wanting to work with. So retrobriting some keys on a keyboard like this, or even a keyboard like this, is probably not a big deal just to take those keys out and put them in a big pot on the stove. So, hey, that's easy. But when you want to scale that up to something as large as, say, a computer case, then things become a little bit more difficult. And, the ozone gas solution might actually be better for large objects. I mean, all you would really need is, something like a big Ziploc bag that's like a lot bigger than this, that you could inflate with the gas and then, leave it out in the sun for, 8 hours or however long it takes in order for the treatment to work. So the problem is I haven't been able to find a bag that big that can seal. Now, I'm sure I'll eventually find one. I'll probably have to order one online, so I didn't have time to do it for this video, but I actually think that will work, and it may end up being the easiest solution for getting a uniform, as in, non-streaking Retrobrite appearance for some of the larger case pieces. So that'll be an experiment I'll be doing sometime soon. So next it was time to attempt a Retrobrite on this essentially brown Macintosh LC2. Of course, first I had to clean it up, and one of the great things I love about the LC series is how easy they are to take apart. You can pretty much disassemble the entire thing without even needing a screwdriver. During cleaning, I did manage to slice my pinky finger open, which was lovely. I did that here on this shield when I was scrubbing back and forth trying to get some of the gunk cleaned off. Anyway, this is the result after a good cleaning. I also decided to pop out this little card slot on the back here because I wanted to have a control to compare the finished product and see how much it changed. I really wanted to do the heat method on the Macintosh LC2, but I discovered that scaling that up to a tub large enough to hold the LC2 was actually pretty darn difficult. And I went all over town looking at different hardware stores, trying to find some kind of solution, to find a container and then some way to heat the liquid up inside that container. And I even looked at, for example, using some hot water heater components in a thermostat. And that may be what I eventually have to do in order to accomplish that, but that's going to be a substantial time-consuming project, so I don't have time to do that for this episode. But considering how much retrobriting I actually do, I think it would be a good investment for me to try to build something like that in the near future. So you'll probably be seeing something like that in a few months. In the meantime, I decided to try a little bit new technique, for me anyway. I used a big storage crate and placed the computer in there. Unfortunately, I couldn't really figure out a good way to get both pieces in there, and UV will still play an important role, and I wanted exposure to that. So I decided to just do one piece at a time. Also, since I'm going to just fill this with water, placing them on top of each other would mean even more water, thus diluting the peroxide I'm going to mix with it. And here comes the Salon Care 40 Volume Developer. And I just poured the whole thing in there. By the way, I've been saying this is 40% peroxide, but I was recently corrected on this, and apparently 40 volume doesn't mean 40%. Apparently it's more like 12% peroxide. I covered the top with some clear plastic to help with the greenhouse effect to increase the temperature. After a few hours in the Texas sun, I measured the temperature of the side of the container and found it to be around 130 degrees, although later I measured it at 138. After about 6 hours in the sun, I decided it was time to see what the result was. Even before removing it, I could see a dramatic change. And yes, it was hot. I rinsed all of the peroxide off with the garden sprayer, and the corrosion you see there was already there before I started, but I noticed it did get a little worse, which I sort of expected, but I figured that was better than trying to remove that shield. Time to put in the bottom piece. And here's the result on the top piece. At first glance, it looks immaculate. However, upon further inspection, I can see a very slight tint of yellowing still right in this area, but otherwise, it looks amazing considering how it looked before, and even the badge on the front is just fine. Okay, so the next day it was time to check on the bottom piece of the LC2, and yes, that rock was quite hot, but I needed that because this piece wanted to float. The bottom looks great, but it really wasn't the main problem anyway. The rear is definitely improved, but not as much as I'd like. I suspect this is because it was not getting much direct sunlight since the sides of the container were blocking light from coming in at that angle. Nevertheless, you can see a huge difference with the little slot cover here, so it's still remarkable. In fact, if I put the cover on, it doesn't look too bad just like it is, although that slot cover sticks out like a sore thumb. Okay, so I decided to put that bottom piece back outside in the solution. The sun's already set for today, but it'll be out there again tomorrow, and hopefully another day in the sun will give it, make it look as nice as the top piece does. And I suppose it will have the honor of possibly being the only thing to be retrobrited in the middle of a solar eclipse, because the solar eclipse is coming tomorrow. And of course, here in Dallas, we're not getting a total eclipse. We're getting about 75-80%. So that'll actually interfere with the process a little bit, but I guess it'll be kind of neat to say, hey, my computer was retrobrited in the middle of the eclipse. Anyway, I would love to show that, but I really need to get this video finished. It's taken a lot longer than I originally anticipated. In fact, part of the reason is because I was in New York last week at the Long Island Retro Game Convention, which was pretty cool because it took place inside of an aviation museum, and I got to meet several of you guys there at my booth, so it was nice meeting you. And of course, I'm going to be in Portland again this October for the Retro Game Expo they have there. So I look forward again to seeing many of you guys there. So I hope some of these techniques I showed will help many of you do retrobriting projects on your own, and I hope to follow up eventually with the ozone treatment and see how that works out, and then constructing my tub. So we'll see how all that works out. And so I encourage you to stick around and subscribe if you haven't already. And I'll see you next time.